Good morning, good morning. This is your video for your e-learning day. Your directions in Google Classroom said to first copy down the notes from the assignment into your notebook. You need to do that. You can't just say you've got them electronically. That's not going to work. You need to have that before I see you for class. 2, you need to watch this video. Yes, you need to watch the whole thing. 3, there is a writing component that you will need to complete that will be a grade for your e-learning time. Remember, if we can't show that it works, we won't get to use those days. Now, I could either assign a video on YouTube as someone else teaching you this, or I could make our own video of me teaching this to you. I decided to go with the second, where you watch me explain it to you. So what we're looking at are chemical equations. Chemical equations are a lot like mathematical equations, in that what you start with has to equal what you end with, but they're going to look different. So the substances that you start with are going to be different substances than what you end with, but you have to have the same number of each atom on both sides. So let's look at what that might look like. We start with something called our reactants. Reactants are the materials that you start with. So let's put this into a real world situation. Let's say that we're going to make water. We know that water is made up of H2O. It says that you have 2 hydrogen and 1 oxygen. So those are our reactants, our 2 hydrogen and 1 oxygen. There's 2 different ways that we could write this. We could say you have H2 with the 2 as a subscript plus the oxygen. That would say that you have hydrogen gas, where there's 2 hydrogen atoms that are already chemically combined. The other way that you might see multiple quantities of a single element are with a coefficient of the 2 here. That would say that you have 2 hydrogen, but they're not chemically combined, plus your 1 oxygen. Those are our reactants. That's what we start with. Then we have this funky little symbol. It's an arrow. But that arrow doesn't just mean arrow. The arrow means yields, or to give, or to create, or makes. The yields arrow separates our reactants from what we get at the end, which is our product. The product is simply, what do we end with? When you combine the 2 hydrogen and the oxygen, that gives off, or that yields, using our more scientific vocabulary, H2O. 2 hydrogen, not chemically combined, plus the 1 oxygen will still give us H2O. Does it matter which way that I write my 2? No. Does it matter where I put my 2 here? That will be given to you. Okay? But what we need to recognize right now is that left side, what we started with. Those are our reactants. The arrow, we don't say arrow, we say yields. Product is what we end with. Making sure I didn't forget anything. Now, here's the last thing that you need to know about what was in today's notes. Okay? We start with this. What we started with and what we end with has to have the same number of each type of atom. That's called the law of conservation of matter. The law of conservation of matter. Now, here's the crazy thing. This doesn't just apply to matter. It applies to matter and mass and energy. So I like to group them together. Matter, mass, and good old energy. So when we have that chemical equation with our reactants, then that means that what we start with and what we end with has to be the same. So let's use another example. Nope, sorry. I'm getting my example. Okay. If I have my reactants of magnesium and I add to that HCl, okay, that yields 2 hydrogen plus MgCl. Now, what we need to make sure that we do is we need to make sure that all of our elements are happy. So what we start with has to be what we end with. So if we write out our elements, magnesium, in my reactants I have 1. If there's no coefficient, if there's no number in front of it, that means that you have 1 of that element. Just like in math. If you have a variable with no number by it, that means that you have 1 of that variable. Okay? So we have 1 magnesium here. Our hydrogen. I have 1 hydrogen. And I have 1 chlorine. Pretty simple. In my product, I have 2 hydrogen, 1 magnesium, and 1 chlorine. I know that I have 2 hydrogen because of that little 2 behind the H. Alright? Now, we need smiley faces. We need this number and this number to be the same. If that happens, then we have what's called a balanced chemical equation, and we are compliant with the law of conservation of matter, mass, and energy. If we don't, then we have to do something called balancing the equation. Okay? Because it's not supporting the law of conservation of energy. So I have 1 magnesium here, 1 magnesium here. They're happy. Yay! 1 hydrogen here, 2 hydrogen here. Uh-oh. 1 does not equal 2. That would be a frowny face. 1 chlorine here, 1 chlorine here. We're nice and happy. So, what this says is that this example does not support the law of conservation of matter because my hydrogens are not balanced. Okay? We'll get into at a later date how to make this follow that. But for right now, we need to make sure that you understand how to pull out the number of each element that's present. All right, go ahead and reflect for me, please. And I will see you tomorrow or later today. Bye.